Okay. Yeah, good. Sorry, I think I got trouble in my internet. It speed, there is speed too. Yeah, maybe my internet is not so good. Yeah, okay. So before you have already done about disaster as well, disaster as well, and next after that in the second thing, you know about the system disaster management system in Indonesia, as well as you in handling the disaster management, you have knowledge about using the approach of disaster risk reduction or DRR. That is called PRT, pengurangan risiko bencana. Is the measure what the earthquake disasters using quantitative quantitative method. Actually, the risk equals to the hazard times the vulnerability divided by the amount of second. And then thirdly, you have know how to handle the disaster quick disaster DRR or earthquake disaster risk reduction. Three here. Later you will have 4, 5, 6, and etc. during the of the introduction in engineering. Now we have to study about the universe. Second, about the earth and the tectonic plate to know about earthquake. Yeah, we call earthquake should be quick. Yeah, quick is like the sacking of the place or where we are here. Yeah, where you are, the place where you are, shaking and trembling, and this is the name of earthquake or gempa. Right, the gempa bumi or earthquake should be read sometime earth, something quick, something earthquake in Indonesia. Yeah, so mean that quick is earthquake too because we are in the earth. Yeah, but if you go to another planets, yeah, maybe different names. Yeah, maybe in the Mars there is an earthquake. Maybe you don't know, and then we call it Mars quake. Yeah. But because we are in the Earth, we just call it quake. Yeah. But in English, usually we are using earthquake. Yeah. But in Indonesia, not only earthquake, sometimes only quake in the same. In Java, in usually do. Yeah. And uh, when there is earthquake, so who, what cause earthquakes? Actually, there are many things that could produce earthquakes. Yeah. For example, is the heat of the meteor from outer space. Heat the earth, like in Arizona. If open if you open the YouTube or Google, Google search, you can find there was a big meteor that hit the earth, and then the story and the theory could spread about the diminishing or vanishing the dinosaurs. It this one of the theory, because this is theories. Nowhere maybe it's just probability because using the academic approach reliable then only using story or myths. Okay, and then there is a explosion, yeah, volcano explosion. It could be even a nuclear, yeah, a nuclear bomb, big bomb, or big explosion of the volcano could make earthquake. Yeah. And 10 years ago, in my place here, when I stay here, it's about 3 kilometers or 4 kilometers from the crater of the Merapi, there was a earthquake. Yeah, because of Merapi. Even the quake could be felt. Yeah, could be felt. I felt it in my house close to the ring road. Yeah, not ring road or close to the valley and the Hyatt hotel there, far away from here, but almost 20 kilometers. Big quake before explosion, and also the landslides. There is big mass of landslide. It could make article two of us. You can search also the information if you would like to get more. You can try it. Try it. Open in the Google search. Yeah. But okay, and then the others could be the tectonic plate because of the damage of the tectonic plate. Yeah, there is a dynamic equilibrium of us. So the Earth here could still could work and be home by us. Yeah. We all home in the Earth because the Earth is still exists. The exists because in the down there below us there is a dynamics. Yeah, Earth is moving. The tectonic or plate letter that we call it tectonic or the rock under us under our position moving. Dynamic. Dynamic mean moving. Different place from time to time. Different position from time to time mean dynamics. Static mean stay there every time. Means statics. Dynamic because dynamic in two. having the dynamic equilibrium. So one of the mechanism to equilibrium to balance the forces under us is basing earthquake and volcano explosion. Yeah, so earthquake and volcano explosion are the mechanism that could save our Earth, not explode, because the energy below us still maintained in the uh, proportion, in the proportion. Okay, yeah, thanks. And now, okay, already. Now, but how about the universe? History from universe, universe here in good like dynamics. Second, yeah, from dynamic, and we study from the universe. Yeah, universe. Now here, the universe or alam semesta. The first is because of the big explosion, we call Big Bang. Yeah. But why Big Bang happened? No, many scientists now still trying to find out. But in the Islamic thoughts, Quran told that God, Allah Subhanahu wa Taala told us that state that before it sky and the earth are one, and then become now far, yeah, become far. It is the theory, other theory of after the theory of Big Bang, that the earth, the universe now is exploding, expanding. Yeah, we do know what happened beyond the space, but the theory, one of the theory could that the earth, the not the universe is expanding, so become larger and larger. Okay, become larger and larger. This is Big Bang. Yeah. So the theory could close to the Quran. Quranic said that Allah before is make hands of sky and earth and become make expanded. If we see some place of the sky, yeah, and we go to the universe, with so many galaxy, yeah, galaxies, so the group of solar system of our solar system. Solar system for us is headed by the sun. Sun, yeah. And here's many of the, for example, yeah, if we have Earth, Earth here rotate to rotate around the sun. Actually, that the sun has also other mother, yeah, called mom sun, yeah, mama sun. So the sun, our sun, also rotate the bigger sun, and the bigger sun has also the mother, call it grandparent sun, yeah, also moving, also rotating. So it's very big. We don't know the other one. Maybe there is also the big one, other. So we call it this because of what we call it big, very very big universe, and this was the God told us. I heard them. So actually that Allah is very great. Yeah, the greatest. Saya call Allah Akbar. Because we are here. Where is even not us? Earth or earth is, we don't know the earth. And even where is our sun? There is no, yeah, the sun. There is the moon. There is no. It's very small. You cannot identify it in the big space of this. And then one of the galaxy is this one, yeah, Bima Sakti. It's the one of the galaxy. So galaxy here consists of many solar system, Tata Surya, very big. Maybe the sun is here, yeah. So the Earth is our Earth here is very small again. We don't know yet. This is only one galaxy. One galaxy. If we have so many, maybe million, billion of galaxies in the space. So there is other galaxy here and far away. Many things galaxy like this, very big. So sun and the Earth is very small. That's it. Maybe here, it's very small. So what we call it is very big, and we call praying Allahu Akbar because Allah is big, yeah. And Allah hold all this, make it and process it. No problem for them for Allah. It not sleep even a second, because if Allah sleep and then become chaos. So this is the story about one of the theory before is the Big Bang, after the Big Bang, and a lot of like clouds, but actually the gas is uh, the gas, and then it's very hot, and million of years maybe, million of years become cooler and cooler. Yeah, if cooler mean they make it liquid. Yeah, some gas is very much hot, very hot, and then the reduce some of them the temperature are reduced, yeah, so become liquid, and the other become liquid because they're liquid and then become cooler again and make it some uh, solid state and make it now sometime maybe million of years become like this one, from gas, liquid, and then solid, yeah. And finally here today it's like this one. It is our solar system. No, we don't think about, we don't talk about the above, beyond of this solar system. Our solar system. This is the sun. This is the Earth. This is Saturn. This is Jupiter. Pluto. Pluto is far away here because the path is not even is not rounded like this, but it looks like ellipse. Some scientists thought that Pluto is not the member of the not of the member of the solar system again. Wait a second, because a lot of big chip, yeah, yeah. Okay, how many chips are running around me? Maybe for 25 chips. Yeah. So all left. We continue. And here, Earth is our solar system, Tata Surya. Okay, here is another illustration of our solar system. This is the big sun, and there is a Earth here, and Saturn, and Uranus, and Jupiter, and Neptune, and then Pluto, yeah. Mars, others, Mercury. So the far here is mostly cooler and then become more solid. So the center is the Earth, the sun here, very big, and the form of The sun is gases, so you cannot land it here. So if you go here and then will pass through another place because this is gases, not solid. It's hot, and some other here, powers become cooler and cooler, so they become solid and solid, cooler and this is our Earth now. We focus on our Earth. Small thing in the universe, very, very tiny, very small. We are us. Here we are. In here, yeah, Indonesia. So, you see here, Indonesia. Yeah. And there is Australia here. It's Asia. It's India. It's Japan. This is our Earth. So it's very much around it. And if we could see from the three faces, yeah, from Indonesia here, this is from Indonesia. This is from Indonesia here, yeah. Okay. One second. Here, yeah. So this is from Indonesia. It's other from Suriname because lot of us, our friends in Indonesia, would be stay there, become the people of there. Some of them are still in the Dutch. Yeah. This is if we go to from Mecca, yeah, from Mecca. But there are three view of the earth from here, rounded. This is how we make it rounded like this because the earth are moving, yeah, and rounded, and we call it rotate, yeah, become the simple phase of rotation is rounded. Yeah. Here is the sun. It's very much hot and it's big, very big. Yeah. It's very big diameter, hot. Even the heat could also spread radiate to the earth, and we are alive now. And plantation trees grow. We have minerals too for human being live. I think. And now, how about our earth and tectonic plate? Yeah, from earth and tectonic plate. Yeah, tectonic plate. Yeah. So this one is earth become solid because it's cool. Yeah, but sun is very hot, so it's still gases. Now earth moving, yeah, and rotating far, relatively far from the sun and become cool. Yeah, cool, cold. Yeah, become cold. But yeah, therefore it's solid. The cold is actually only in the outer, or in the we call it crust, on the edge. Yeah, on the only in the cover of this skin. So what are the rest? Mantle, outer core, inner core. It could be a liquid, hot liquid, even inner core could be gases, yeah, like sun, sun, yeah, sun. Okay, so it was this watermelon, yeah, and we cut it. So look like this one, the Earth. Yeah, this is the theory of lot of now the theories could be discussed. Okay, and second, yeah, second, if we cut also the watermelon of the Earth watermelon, yeah, and then only outside this one is the rock, yeah, very hard, but the glacier is still liquid, yeah, because of solid and cold, yeah, become cold and cold, yeah, cooler and cooler, yeah. Therefore, this become shrinked, yeah, become small size and crack everywhere, cracking here and moving. Because why? Because this is sliding above the liquid matters, yeah, liquid earth, liquid of the earth. Call it here the rock here is called we call tectonic plate. Tectonic plate is the rock is very hard, yeah, above the liquid mantle. There's also atmosphere here, so but it's already also very hot liquid. Yeah, this is more liquid than the other lah, more plastic, like plastic, and this is moving. Why? Because there is a convection theory of convection. The convection state that the hot liquid could go out, yeah, will go, but will go to the cooler, cool liquid, and the cooler liquid going to down to go to press, yeah, hot plate because of the gravity, yeah, specific gravity, maybe more the density. Look like that we boil the water, boil the water, you know, see about the water, see about the moving or rounding the water, like that there is a spring down there. Okay, and if we continue, so this is the place where there is moving and restrained by others. There is moving. The moving of the tectonic plate here is differ each other, differ in direction and differ from speed. Speed and the direction of speed is different. Therefore, there is a collision. There is a subtraction. There is a yes, what we call it shears, yeah, each other, crash each other. For example, here the Australian tectonic into Australia, going to the north and sleeping us and sleeping and sleep and moving beneath the European and Asian plate, tectonic plate. We are here, look like this Parangtritis, yeah, Baron, Samas, yeah, Lagah, Kulon Progo here. So this is Merapi. So look like this one. There is a end line, yeah, line of order of volcano. So if there is moving, different speed and different direction, even this opposite direction, so will move. There is a bigger and bigger energy accumulate, and sometimes the energy beyond the happen, yeah, as big as or over than the strength of the tectonic plate. So there is broken and break. Suddenly and become earthquake. If not, there is a big compression here. There is will come to volcano, become the forming the volcano, become volcano erupts. So this is the tectonic plate move, yeah, because of sliding of the ionosphere, liquid, then moving from year to year until, for example, 150 years, million years here. Here to 237 years ago, there are only one big land, and then the other are ocean. Ocean. Here is Pangea. Then become moving and moving. And this is the early Triassic part. Yeah, there's Jurassic Park, Triassic Park. It's good for the story, making story the mind and the imagination for us. And the time before Allah create the human being. There are many stories and big movies, yeah, for our entertainment. Yeah. So this is moving every time, yeah, moving here the right side and become many continents. Yeah. These 5 continents now: Asia, European, yeah, European continent, Europe, Australia, and small India. Actually, India is different continent before, but collide to Asia continent, Asia plate here, India continent plate become many peaks are there, and even there is a Mount Everest. It is very big and tall mountain as far as Himalaya mountain. There is a big Mount Everest. It, the people thought that Everest is become higher and higher elevation. So the elevation become higher and higher every time. So Mount Everest actually that there will be still moving up, yeah, moving up because of India, right with Asia here, Australia, Europe, and Africa, and then America. Yeah, South America and Africa usually before is become one. Yeah, so look like there is a shape that it could be one before and crack. Yeah, crack. Okay. Now, how about the other stories? The stories of being here. Stories about the moving of tectonic or dynamic of the earth. Yeah, geological dynamics. Moving here, everything moving. Yeah, so there is a life here because of it's moving. Okay, now we back to see the theory of Earth. Yeah, okay, by the Australian government. Yeah, Australian government. Uh, and
Expedition season will be visiting some subduction volcanoes off the coasts of Greece and Italy. And here's the science behind how they're formed. It all starts when seawater seeps down into the cracks within the sea floor. This changes the composition of the ocean crust, making it saturated. There are areas on the Earth's surface where the ocean crust is forced down beneath another tectonic plate, and this is called a subduction zone. At a subduction zone, the saturated ocean floor is pushed to regions of high temperature and pressure. an environment ripe for volcano formation. Under these conditions, the ocean crust begins to change, and it releases a watery mix that was stored inside it. This water combines with the rock above, melting it and forming small pockets of melted rock. These pockets travel up into the overlying plate, forming magma chambers. This magma continues to move through different layers of crust, changing composition as it goes, and when it finally reaches the surface, it creates a powerful volcanic eruption. This Nautilus expedition season, we will be exploring underwater volcanoes, looking for hydrothermal vents and taking water, gas, and geologic samples to look at the chemical composition of the rocks and water. These analyses help us track the activity of the volcanoes. And in addition to using the data for scientific research purposes, we hope our work on the Nautilus will help provide warning for future volcanic eruptions. Again, I'm Jessica here at Nautilus Mission Control. Stay tuned at nautiluslive.org for more live exploration. Nautilus visiting some of the science behind how they're formed.
Ya, kita coba untuk mencari ini apa informasi yang mendekati teori kita. Nah ini tentang tectonic ya, tectonic plate theory that shrink and then become bending, release the energy become a tsunami. So the release of energy become big earthquake, tsunami, even volcanic eruption. This is already before. Okay, we'll see here.
Hi everyone. We're going to look in this animation at how the movements of the Earth's plates controls volcanic activity on the Earth. Let's look first at what's called continental rift volcanism. Now, in places where forces are causing the Earth's plates to stretch, especially in the continents, a couple of different things can happen. In this part of the animation, you can see there's what's called a rift valley, where the crust is ripped apart and it sinks down to form a valley. That's kind of like the East African Rift Valley, or much of the western United States in Nevada is like this. Or you can simply get cracks in the crust that will allow magma from the mantle to rise up. In either of these situations, what we call continental rifting, we get volcanoes to form because as the plates separate, it allows the mantle to rise upward. Really what happens is the separation of the plates depressurizes the mantle underneath. There's not as much weight on top, and that reduction in pressure allows the hot rock of the mantle to actually melt. Now, more important even than that is the kind of volcanic activity that happens as associated with subduction. In this animation, we're going to subduct some ocean floor underneath the edge of a continent. And as that happens, as you know, you get an ocean trench, but at a certain depth, about 80 miles down in the Earth, the subduction of the plate triggers melting of the mantle, and that magma rises, and a whole series of volcanoes begins to pop up along the edge of the continent parallel to the trench. We call this a continental volcanic arc. The Andes Mountains are a classic example of such a system. Now, another thing we can do is have, instead of ocean floor subducting underneath continent, we could have ocean floor subducting under other ocean floor. In this case, the animation is flipped around, but it doesn't really matter. You can imagine either of these in a mirror image. Same process. We're going to subduct the ocean floor underneath this other ocean floor. We're going to generate magma. The magma is going to rise.
There's this
a whole series of volcanic islands is going to pop up
making island and also
you see how it's very similar to the continental situation. The only difference
of the
is that the
dynamic
volcanoes
of
are
the
popping up out of the
earth,
ocean parallel to the trench instead
tectonic
of
moving
on land
each other.
parallel to the trench. Okay, so an
subduction.
example of this would be the Aleutian Islands, say, or the Philippines, or the Marianas Islands in the Pacific. These are
The subduction
we
like
call
in Australia and
volcanic
Asia.
island arcs.
Yeah,
Volcanic island arcs.
they are as close to.
Now, the other main source of volcanic activity on Earth are what we call hotspots.
There is
Hotspots,
trench.
in a situation like this, there's magma being generated all along a long
Yeah.
line. Hotspots are situations where magma forms in just one local area. And we think these hotspots form because of large blobs or columns of magma that rise from deep in the mantle. We call these mantle plumes. And as tectonic plates move across mantle plumes, if mantle plumes stay in one place, and there's controversy about whether they do, but let's assume the plume stays in one place, it'll make a volcano. The volcano will get carried away. Another volcano will form. It'll get carried away on the moving plate. And yet another volcano will form, and it'll get carried away. And you get a chain of hotspot volcanic islands. This is a classic example of how, for example, the Hawaiian Islands formed. All in a line, one after the other, as they moved across a hotspot. Let's back this up again, and we'll show one volcano, then another, and then another, forming over the hotspot. So those are the main reasons and processes by which the Earth makes volcanic activity.
Yeah, there's volcanic activities. I have a relationship.
Hi everyone.
With the
I figured I'd throw together a quick video just to review some of the content you've been working on in class. Let's get started. Obviously, you've been working on this theory called plate. The first thing we need to know is this. The outer shell of the Earth, which I gave an example of being the magic shell on a scoop of ice cream, this solid outer crust of the Earth, we call it the lithosphere. It's actually broken into pieces that we call plates. You see them here. You can call them lithospheric plates, you can call them tectonic plates, or simply plates. But this is the solid outer part of the Earth that we...
Example here, there is African plates. There is in Australia, India, so Indo-Australia, and there is a Asia, European, in European, Eurasia plate, and there is a Pacific. There is a Philippines plate, and American plate too. Yeah, see there is American plate here. So actually, that there are many volcanic plates. So back that is strong, big, strong rock, yeah, in us, and they are moving each other in different speed and different direction.
We live on. Some of the plates are all oceanic crust, some of them are all continental, and some are a combination of the two. That's going to become important.
Tectonic.
Keep in mind that we do have these two distinct types of crust. If you look at the gray here, this is our continental crust. It's thick, it's made of the rock granite, it's not quite that dense, only about 2.7 grams per cubic centimeter. But if you look at the dark gray area under the oceans, that's the oceanic crust. It's very different. It's much thinner, more dense because it's made of the rock basalt. The density of the basalt is about 3 grams per cubic centimeter. Keep in mind that information can be found on your Earth's interior chart in your reference areas. Now, that crust, whether it's oceanic or continental, along with this kind of orangey section called the rigid mantle, those two together are what make up our lithosphere, this solid outer shell of the Earth. Keep in mind that beneath that is kind of a gooey, plastic, partially melted bubblegum layer called the asthenosphere. And so the plates that we live on are actually floating on the asthenosphere beneath. Now down in the asthenosphere, that melty, gooey, bubblegum-like rock is actually able to move. And it moves because of a process known as convection. Essentially, convection says that hot material becomes less dense and rises. And then when it rises, it cools down, becomes more dense, and sinks. And what we end up with are these rising and sinking currents called convection cells in the mantle. Those end up being the machine, the force that is driving the motion of the plates. So in this diagram, we have a type of boundary called a divergent boundary, where the plates are literally being ripped apart by the movement of the convection beneath. Keep in mind this convection takes place. It's very similar map in
You
your
see
reference
here
table, which
is
we'll see shortly. But for the moment, take a
the,
look.
the
You
arrows
notice
here
that the
are
plates, some are very large, some are a little bit smaller,
identify the
but they're all
direction of the
moving.
motion.
And what that means is that there's lots of action
There
at the
is a
places
shear
where
here,
plates meet.
shearing.
For example, that's where we find all our
There
earthquakes,
is also
shown here
here.
with pink dots. That's where we find all our volcanoes, shown here with red triangles. And this is also where we find a lot of the Earth's active mountain ranges. So keep in mind that all seismic activity, earthquakes, volcanoes, and mountains, tends to happen at or near these boundaries
American
between
plate.
plates.
Ta-da!
Okay.
After 3 months, I could understand
Secondly, we
about
have to
80 to 90% the content of the English news without subtitles.
Which brings us to those boundaries themselves. Now,
I think here is
all of plate tectonics comes down to the
have
fact that
paid for
things
us.
happen when two plates interact with one another. So we, as seen by these arrows,
Boundaries,
into
yeah,
things we see
transform,
at each of them. So
convergent,
let's go into some
divergent.
examples here. Okay,
Yeah, there are
I'm
three.
going to be alluding to form boundaries. So
So
these are the boundaries
we'll
where
later
plates slide past
we'll
one another.
study about this one.
If you take a look at this
There
animation,
is
you'll
the
notice the
mechanism
lithosphere floating
of
on
the
top of
moving.
the
Yeah.
asthenosphere is being driven by
So there is
convection currents,
earthquake.
which is causing them to
This
slide
is boundary.
laterally past each other, right past each other,
Yeah.
which is often released in the form of earthquakes. Transform boundaries
So
on Earth where you can
if you
actually
can see
see a
from
transform
above,
boundary
like
at
in
the
Sumatra.
surface. This is known as the San Andreas Fault, and it's found in California. It's responsible for the big earthquake risk of cities like San Francisco and LA.
Palu.
Let's go back to our reference table for a minute here.
So
and see that the transform boundaries are shown down on the bottom with this symbol, shown in green here. There's a work, the arrows kind of reveal what is involved. For example, we see different things happening when it's oceanic crust colliding with oceanic crust, as opposed to when it's continental colliding with continental, and so forth. And so we have a few different types of convergent boundaries. The first type we call subduction zone, and as you can tell by this little animation here, this happens when continental crust on the left collides with oceanic crust on the right. Now notice that the oceanic crust is sinking underneath the continental crust, and that's because oceanic crust is more dense than continental crust. It's heavier. And so when the two collide, the heavier oceanic crust sinks underneath the lighter continental crust. When it sinks, it melts because it's hot down in the asthenosphere. And that melting rock finds little cracks and crevices to rise through, and ultimately erupts at the surface, forming active volcanoes. They both have the same density. But eventually one plate, usually the older rock, will sink under the younger rock. And again, we will get this melting, which causes rise. If I go back to the chart here, we also have
Hi, I'm Dr. Amy Killen. I have my own medical practice, and I've been using Doodly now for a few weeks.
Boundaries can be seen with this symbol down here, because it's a subduction zone that each other. Again, we want to consider the type of crust involved. So if it happens on land, we have what's called a rift zone, where the land actually rips apart into two. We see this happening in Eastern Africa right now at an area known as the East African Rift Zone. As you can imagine, when the rock rips apart, it allows magma to escape. So we get active volcanoes. We do get some minor earthquakes here, though they're not as significant as the convergent boundary. The magma is coming up in the middle, forming mountains and volcanoes, and again, some earthquakes. Now, there's one tricky thing of this. As you get further away from the ridge, are these alternating bands of magnetism which match up on either side. And the most common one is probably the one that spans the Atlantic Ocean, the mid-volcanoes that weren't a boundary here. We're talking about one simple, individual, solitary point where you have active magma rising up. And it rises from something called a plume. We can't predict where these will happen. We notice there's maybe a dozen of them right now. Sometimes they're very active, sometimes they're not as active. Here's how they work. If you look at this diagram, you're going to notice shortly a mantle plume. There it is, coming up from the asthenosphere. It's just a hot spot. And that magma, so you'll get this active volcano, which is then dragged to the side, making way for a new active volcano to form. And then that is dragged to the side, and a new one will form, and so forth. And so what you end up with is this chain of islands, if it's happening in the ocean, with one active volcano over the hotspot, and then a chain of extinct or dormant, not active volcanoes extending away from it. And what's cool about this is if you look at where the extinct volcanoes are, they tell you the direction that the plate is moving. So that's pretty much in a nutshell the...
You can see here, so many things. It's very interesting. You can do it. You can study for this because now it's easier for you to find many information. Yeah, this one already we finished, and then of course we go here. Yeah. There is crack or maybe a damaging tectonic plate, crack and become tectonic plate, not like explosion of bomb. Of course not. Yeah, because this is sometimes long, the long range, long because long damage. So it's not pointed like this one. Long and release the energy because of the accumulation energy release, and there is a moving vibration here, spreading around in many direction, all direction, including in the surface of the earth, and become there is a surface waves traveling and shaking our place. This one, yeah, ready before. It's okay. Yeah. So that way there is a ring of fire because there is a moving between this is a big Pacific tectonic collide with Australia, Eurasia, and then North America, South America. So there is become the having so many volcanoes. So during moving and releasing the energy, or maybe volcanic eruption. So like in Indonesia here, there is a into Australia. So there is a the direction into Australia going to the north. There is a Pacific. There's Eurasia. So there are a lot of earthquake here. This is the damage of plates, yeah, tectonic plate during in the surrounding, yeah, close to the subduction zone. Some of them are cracked in we call it fault, fault here. It is in we call it in the islands or continent. Yeah. This is in the ocean. This is a continent or island. So here is the unique thing is in Sulawesi, because before there are two islands of having the Eurasia and island using having it by the Australia. So there is a writing here, so become like in Palu, yeah, Palu, Jiki, Donggala. There is a Yantirpune here, and in southeast Sulawesi, near Kendari itu, there is also fault here. So this peak in 2018 Central Sulawesi. Here is the data from 73 to 2004 years before. So there is here, there is no many earthquake here. After there is some earthquake after that. So like they call it the seismic gaps. Become lighter, there is a earthquake happen here because the energy is still accumulate, and the plate is restrained, still having having enough strong enough to resist the accumulative energy, accumulative energy. If not, then become broken and become earthquake. Yeah. So there are three. It's very in Maluku, yeah, Maluku, so crowded, and even in close to the Maluku, yeah, Papua also big, Java, Matra, so many big happen, and there is a crack inside of the Java Island to make some earthquake before and maybe potential for the coming time, yeah. As about the effects, yeah, cause and effect, why earthquake could turn into disaster, because there are at least three mechanisms in Central Sulawesi. The big earthquake in 2018 was about 7. I identify 7 mechanism earthquake to become disasters, to change, bring to the disaster. But we have already have our explanation before. If you like to have a explanation about tsunami, because of earthquake, tsunami, and landsliding, shaking, big shaking, as you can see, you can open search, search YouTube, or maybe you can study later, because before you have already studied about the disaster from the introduction to disaster study, and I gave you to what to meetings of that scope and knowledge about the disaster and earthquake disaster and handle it. Okay, later, and then we already here. And write down you better write down your okay. Now write down this one, yeah, to make sure that you follow me, yeah. Still in the lecture here. If not, right, IEE-04 number of attendance rates and student short name, your name, yeah, your student, and send to passenger your assistance, and the sport person Masari, yeah. That, but you have to have numbers, special numbers.
What is the code, sir?
Wait, but see, yeah, here, write down small number of Oxford attendance. Send the WhatsApp